1, 2, 3, come on!
Today we will look at carboxylic acids. Carboxylic acids are given with the formula of RC double bond O and OH. This is one example of carboxylic acid, which is it has two carbons, so it is known as ethanoic acid. Now let's look at how do we get carboxylic acid. Okay, we get our carboxylic acid from the previous reaction we have learned under halogenoalkanes. Halogenoalkanes can react with KCN under the ethanolic condition when you heat them under reflux. Okay, when you heat them under reflux, what is going to happen is going to be you are going to get RCN is a nitrile, and you will have KX. Now this nitrile that you get over here, they can react with dilute HCl heated under reflux, to give you carboxylic acid. So if we take this example, let's say if you have a halogenoalkane CH3Cl, and when you react with KCN, it will give you the nitrile CH3CN. This is nucleophilic substitution reaction we have learned earlier, and you will get KCl. So what is going to happen next is going to be this nitrile that we form over there. They will react under reflux with dilute hydrochloric acid, and the reaction is going to be it will react with 2 moles of water and 1 mole of HCl to give you CH3COOH and NH4Cl, ammonium chloride. Okay, so if we want to actually look at it in more detail, if let's say I write this molecule, this particular molecule over here, if you have for example CH3 C triple bond N, and it is reacting with water and reflux with dilute hydrochloric acid, so you will have water and HCl. What is going to happen over here is the nitrogen, the nitrogen and then the carbon, they will start to have hydrogen. You see one hydrogen, one atom of hydrogen, second atom of hydrogen join over there. The same with nitrogen. Nitrogen can form 3 bonds, so you have the third hydrogen over there and the fourth hydrogen come over there. And what is going to happen next is going to be you are going to have this particular hydrogen all will be lost, because you are going to form a carboxylic acid group. So it's going to be you are going to lose all the 4 hydrogen, and they will be lost in ammonium. And then this nitrogen also will come over here, NH4. And what is going to happen over here, you are going to have 2 more oxygen, 2 moles of oxygen, and 1 H over here left over here. So in total, what happens over here, you are going to have on the right hand side of the equation, you have 5 moles of hydrogen, 4 from here and 1 from here, and we have 2 moles of oxygen. So if you look at it over here, if water and HCl, you need 2 moles of oxygen, you just need to put 2 there, 2 moles of oxygen. And since we need 5 moles of hydrogen, you can see 2 and 2 over there, that's 4. So this is going to be H 1 more, so it's 5. So no need to put any number in front of H. And we have 1 Cl over there and 1 Cl over there. So in summary, if I write this in form of a proper reaction, RCN, if I represent this as RCN, when you react with 2 moles of water, it will give will react with 1 moles of HCl, it will give you the R carboxylic acid, and ammonium chloride. Okay, this is going to be the reaction that will be happening. Basically, you are going to get carboxylic acid, okay, from the nitrile group, but you need to actually react with dilute HCl heated under reflux. Now let's actually look at the reactions that the carboxylic acid will undergo. The first reaction is actually not a reaction, they will behave as a weak acid. Okay, therefore, okay, this weak acid, carboxylic acid, they will partially ionize in water. It means there is no complete ionization in water, so we need to represent the arrow over here in a reversible reaction. So this is going to be a reversible arrow. If I represent this using ethanoic acid, okay, you are going to get ethanoic salt and then H plus over there, so it's going to be partially ionized. Now apart from that, okay, carboxylic acid, okay, they will actually go through all the reactions that a normal acid will undergo. One of it is going to be reaction with metals, second is going to be reaction with carbonates. Okay, and if you look at the reaction with metals, it's going to be, you are going to be able to react, okay, with sodium, okay, sodium, to give you salt and hydrogen gas. So this is going to be the salt and this is going to be hydrogen gas. If I represent, okay, using equation, you can see that, okay, ethanoic acid react with sodium to give you the salt and then hydrogen gas. If you have with magnesium, similar reaction will happen, you will get the salt and you have the hydrogen. Now do remember, we still have one more reaction over here, I didn't write just now. Okay, the another reaction is going to be carboxylic acid, they will actually react with sodium hydroxide. Okay, so reaction with hydroxide or alkali, okay, with alkalis. So the reaction with alkalis will be something like this. If you have RCOOH, when you react with sodium hydroxide, for example, they are going to give you the RCOO minus Na plus and then H2O. This is going to be, they will behave something like weak acid. Okay, so they are going to actually give you salt and they will give you water. So this is going to be something like a neutralization reaction. Now apart from that, you will also have the reaction with carbonates. The reaction with carbonates, they are going to give you salt, water and carbon dioxide. So if you have RCOOH with sodium carbonate, you will get something like this with water and carbon dioxide. Okay, so if we have an example over here, if I have 2CH3COOH, when I react with sodium carbonate, I am going to get 2CH3COO minus Na plus and plus with water and carbon dioxide. So this one, okay, if you want to actually find out what will happen with the reaction with carbonates, there is going to be a gas that turns the lime water to cloudy will be released. Okay, now the last part over here is going to be the reduction. Now the reduction is going to be something going to be reversed to oxidation. We have learned that primary alcohol, they can be oxidized, okay, to become aldehyde, and aldehyde can be further oxidized to become carboxylic acid. But now it's going to be the other way around. Carboxylic acid can be reduced, okay, to become if this is oxidation, so you can actually reduce that, okay, to become primary alcohol. So you can get primary alcohol. The catalyst that you need over here is going to be LiAlH4 in dry ether at room temperature. So you need to actually memorize this. Okay, lithium tetrahydroaluminate. Okay, lithium tetrahydroaluminate in dry ether at room temperature will make the carboxylic acid change into primary alcohol. So if I actually write down in form of equations over here, have a carboxylic acid. Okay, this carboxylic acid, when you actually react with this HB reduction, Okay, so what's going to happen is going to be you have the CH3C, and then you have H, and then the OH will stay. So that's going to be 1 hydrogen, 2 hydrogen. So what happened to this O? The O will come out, and then you will have another hydrogen over here. That's hydrogen number 2. So you have OH, and then you will need another one more hydrogen. So this is going to be hydrogen number 3, hydrogen number 4, okay, to give you water. So it's going to give you water. So how many hydrogen you need? You need 4 at hydrogen over there. So this is going to be complete. So incomplete in the end. It's going to be, if you want to write the equation, it's going to be CH3 COOH when you react with 4H over here, and then you are going to get CH3 CH2 OH plus H2O. Okay, so if you want to write it down in form of RCOOH plus 4H, and you are going to get RCH2OH plus H2O. That's it. Okay, I hope you understand about this. Okay, this is going to be all the reactions involving carboxylic acid. Okay, so we started with how do you get the carboxylic acid. So you are going to get the carboxylic acid from the reaction of halogenal alkane with KCN to give you the nitrile, and this nitrile can actually react with a dilute hydrochloric acid, okay, and reflux, and it will give you carboxylic acid and ammonium chloride. Once you get that, okay, you have some of the reaction with weak acid. Okay, it's partially ionized. You can react with metal, you can react with alkali, you can react with carbonates, and then the last one is going to be reacting with lithium tetrahydroaluminate for reduction to give you the primary alcohol, and we have done the equation involving the primary alcohol. So basically what is going to happen, there are 4 new atoms of hydrogen will be there, so you can just write it down over there. So that's all for today. So thank you guys, take care.
Kick. Hey, hey, hey.